Hi everybody, Patrick here from EngineeringShock.com, electroniclessons.com, and paintballprops.com. Today we're going to do the final video manual for the multi-program Arduino compatible laser tripwire set, the 3-volt regulator for your laser beam, or beams, depending on which pledge you made into the Kickstarter campaign, if you made a pledge, the loud siren, the wireless transmitter and receiver, and AC adapters. There's a lot more to be seen on Kickstarter. If you're interested, have a look at the Kickstarter link below. First, we'll talk about the laser operation, and then we'll talk about the processor board afterwards. The laser setup is extremely simple. There's a laser fixture that's adjusted via 2 screws on each side. It comes with mounting hardware, and it can be adjusted on many axes. The laser head can be focused or unfocused to make the laser beam larger at the other end, but not as strong, or focused into a very small dot, and the distance is much greater. Very, very simple. The 9-volt AC adapter connects to the input terminal block, the laser to the output terminal block. Now let's talk about the regulator right here. There's an on-off switch right in the middle, and both sides has the labeling of on or off. And what this board does is it takes anywhere from 4 to 15 volts DC and regulates it down to a safe 3 volts for the laser module. Both sides of the module have a terminal block. On the input terminal block there is a pin labeled in plus, and the bottom is in minus. In plus is where you connect your red wire, your positive 4 to 15 volts DC, and the bottom, in minus, is where you connect your supply ground. Now there's also soldering pins in case you want to solder as a long-term thing, as opposed to using the terminal blocks. There's mounting holes here, 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 and here, and the output terminal is where you connect your laser. There's a pin labeled 3V for 3 volts and GD for ground. You connect your laser output where you measure 3 volts. This is the regulated output. You connect your red positive input wire to your laser to the 3-volt line, and your negative to the laser to the GD line. So it's very, very simple to use. You plug it into the wall, and you use your on-off switch to turn your laser on and off. This allows for you to use an AC to DC adapter to power your laser. Right now I have the AC adapter plugged into the wall. I've got the switch on, set to on position. I can turn it off. I can turn it on again. Now let's look at the focusing option. Right now I've got the laser pointed about 2.5 meters away, so I'm going to, my hand might get in the way here. I'm going to focus it, and as you can see, it becomes a smaller beam, which makes it harder to line up with your sensors, but it means that the beam can travel a heck of a lot farther. Now the board dangles from the laser wire by about 4 inches, 5 inches. You want to make sure that you mount it to something, especially when power is connected, because you don't want it shorting on the mounting hardware. So when you mount your laser mount, you want to make sure that you also find a way to properly mount your regulator board. And as I said, there's a mounting hole here, 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 and here. It's extremely easy to use. Let's have a quick overview before we continue with the programs. This is your power supply area. It requires a power supply of 9 volts to 12 volts DC at 1 amp. This is your cell button, select button. It's used in laser tripwire 1 and laser tripwire 2 modes. This is your siren connector. This is your wireless receiver module. That's included in some Kickstarter reward tiers. Your light dependent resistors are here, 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 and here. Left, right, up, and down. And they correspond to the output LEDs. The output LEDs can be disabled by removing the LED_EN or LED enable jumper. Right now I have them enabled because I've got a 2-pin jumper connecting the 2 pins. The output rail is labeled VCC for 5 volts. It's a regulated 5-volt line to connect to an external peripheral like Arduino. GND, which is ground. L for left, U for up, D for down, R for right. And the LEDs are also labeled left, up, down, and right, or LUDR. This is your program select jumper, or rail rather. Right now I've got a 2-pin header shorting PG1 for program 1, and that is gesture mode. PG2 is shadow mode. PG3 is laser tripwire 1 mode, and PG4 is laser tripwire 2 mode. So I use this rail to select which program I'm running on power up. This is your indicator LED. It cannot be disabled. It's run by the processor directly. And this is your sub-program select. And you will use that for sub-program options for laser tripwire 1, laser tripwire 2, and shadow mode. So right now, we don't have anything connecting, we don't have a jumper connecting anything on the sub-program jumper because we don't need it. We're going to start off in program 1, which is gesture mode. Now let's plug it in and we'll have a look at gesture mode. Gesture mode is not a laser tripwire mode, it is an Arduino compatible mode, and what I'll do is I'll plug it in, and as soon as you plug it in, each LDR is waiting for a change in light. So if I cast a shadow over the left, the L LED lights up. If I cast a shadow over or make a change in light over the lower LDR, the down LED turns on, and the relative output goes high, the D output goes high. Right LED and the up LED. So if I want to cast my hand over this way, the left LED will turn on. As long as I hit the right LDR first, the right LED will turn on. Same with down and up. That's shadow mode. Very, very simple. I've written an Arduino sample code that will be included in the written manual for download, and it easily connects to Arduino. How to connect to Arduino? You just need to connect your ground line, your GND, to your powered Arduino, and your left, up, down, and right outputs to whatever Arduino pins you want to use for communication from your processor board to your Arduino. I now have the board set to shadow mode. What I've done is I've taken a 2-pin header and I've shorted the PG2 pins. PG2 is shadow mode. And I've got another 2-pin header shorting the middle and left pins on the sub-program jumper. And this puts us in toggle mode. In this version, also in Arduino compatible mode, the rightmost LED and the R output are only used. We don't use any of the other ones. Basically, this scans for a change in light on any of the LDRs. And it's a very fast change in light. And it's very reactive. So one breach, toggles on, toggles off, toggles on, toggles off, toggles on, toggles off, and the same goes for any of the LDRs. It's the same LED, same output. We're just using one output for shadow mode. Shadow mode is very, very simple, and it allows for you to easily toggle on and toggle off, say, a relay, or to tell your Arduino something is on and wait for, again, until that output goes low to tell us that something is off, that there's been a change in light. So what happens if I unplug power and I connect the middle and right pins on the sub-program connector? I did not mean to say that. You actually don't need to turn it off. You can change modes on the fly, for sub-program modes on the fly. So now, the output is momentary. The output goes high for roughly 250 milliseconds, so 1/4 of a second, every time the board detects a change in light. And it's very, very, very sensitive, which is perfect. So as long as you've got a decent amount of light, right now we've only got a little bit of light on the board. Even if we have a little bit less than this, it would still work very nicely. It's just picking up changes in light. Very simple. I'm now set up for program 3, which is laser tripwire 1. And in this mode we have two options. We use either the bottom light dependent resistor or we use the bottom and the top. And in this mode what happens is when it's active, when I break the beam, the siren will go off until I stop breaking the beam. Now with the sub-program connector header shorted with the middle and right pins, only the bottom light dependent resistor will sense this change. Now you want to make sure that before you set this up that you have your laser pointed at the bottom LDR. Now we'll go through the second mode, which is if you have the header shorting the middle and the left pins of the sub-program header, in which case the top light dependent resistor and the bottom light dependent resistor are sensing. So lasers have to be placed on both of these resistors, or light dependent resistors. So now I'm going to take my power, I'm going to power it up. We'll talk about the wireless activation and deactivation after. So it's powered up, Nothing happens. That's good. You want to make sure that you have your laser set up perfectly beforehand. Now, also, what I'm going to do is I'm going to take my siren and I'm going to connect it to the siren connector block. And now we're ready to go. So I'll activate it. And you see the LED scroll from left to right? That tells me, okay, system's activated, and you see that the indicator LED is turned on. That's telling me, that's a visual indicator telling me, okay, you're on, this means business. So as soon as I break the laser beam, so that's it. Now I can press the sell button and deactivate the system. Now it's okay. So let's look at the operation with the subprogram jumper placed on the middle and left pins, and we'll shine another laser on the top light dependent resistor. As you can see, I now have a laser pointed at the top and bottom. It's powered up, still with the header shorting the middle and left pins. So now what I'll do is I'll enable the system. The LEDs scroll right, and the indicator LED turn on, telling me, okay, system's active. So both. Very, very simple. So this allows for you to have two lasers bouncing off mirrors to those top and bottom LDRs. Now I'll just deactivate the system. Sorry, I bounced the board and the bottom laser went off the board for a second. So yeah, that's laser tripwire 1 mode, but we haven't talked about our wireless transmitter and receiver. Now, let's just power it up in the same mode, but we power it down first. And now what we want to do to enable wireless communication, what I want to do is as soon as I power it up, I want to hold down the sell button. And after a second, let go. And you might have noticed that the indicator LEDs scrolled from left to right 3 times. That tells me that the wireless transmitter and receiver are now talking to the board. So if I press any button on the transmitter and let go, I've wirelessly activated the circuit. So I can set up my lasers, leave the room, activate it, and it's active. What if I deactivate it? Activate it. Deactivate it. So very, 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 very simple. In the final program, I take the 2-pin header and I connect the leftmost pins labeled the PG4, and that'll put us into our primary mode. Now for this mode, you can use not 1, not 2, not 3, but 4 lasers. You can use 1, 2, 4, or any in between. Bounce them off walls, make a huge grid across your room. We're only going to use 2 for this part of the video because I'm in a small workspace right now. I don't have it mounted on the wall anymore, and so I can only fit 2 lasers in here. So I'm going to power it up with the header connecting the middle and right pins on the sub-program connector, and that'll put us in timer mode. So I can activate it. Now our system is active. Now if any of our lasers are breached, it doesn't matter which one, any of them. If any of them detect any quick change in light, and it's very sensitive, what will happen is the indicator LED, which is on right now, will blink on and off and give you about 10 seconds to press the sell button to deactivate the system. So I'll breach a laser. I can deactivate it. And there we go. So system's deactivated. So I'll press the sell button again to reactivate. Breach a sensor. If I wait it out, I'm covering up the siren because it's very loud. Once that LED goes out, you can deactivate it. Now, what I'll do is I'll activate it again. I'll show you this one more time. So you activate it. I'll wait out the 10 seconds, and the LED will turn on and stay on. And once it turns off, I can deactivate it. So once the siren is enabled, you have to wait 5 seconds before you can turn it off. So I'll reactivate the system, breach it. Now watch the LED. On. Off. Only after that LED turns off can you deactivate the system. So what happens if I connect my my subprogram header to the left and middle pins? And I can do that on the fly. Just have to make sure that my lasers are still lined up after. Okay, so now I'll activate the system. And in this mode, there's no timer. There's no countdown timer. As soon as you breach it, that alarm goes off. And once the LED turns off, then you can deactivate it. So let's try wireless control for this mode. It doesn't matter if you're in timer mode or non-timer mode using the subprogram jumper. You can still use wireless control with this mode. So just plug it in like before. Hold down the cell button. Let go. We get 3 scrolls of the LEDs telling us, okay, now we're connected to the wireless control. I'll press any button on my transmitter. Our system's active. The LED is on. I'll deactivate it. I'll trip it. Oh, I've turned it off. Sorry, I'll turn it back on again. So, active, deactivated, activated, deactivated, and again when it's deactivated nothing happens. If I activate it and I breach it, and there we go. So what happens if we change the program select jumper or sub select jumper to the middle and right pins? Now we're in timer mode. So I'll enable the system wirelessly. I'll breach it. We're in timer mode, and I'll deactivate it wirelessly. And if you, by default, if you have the antenna up, you can push it down, you can pull it up. As long as you have the antenna up, you can do this from anywhere across your house. If you want an even longer distance, there's a little pin on the upper right of the receiver board labeled ANT, and what you do is you can solder in a straight 17.3 centimeter wire to get you even more distance. So let's talk about the transmitter. The transmitter keychain has a protective cover that can click into place up or be pulled down. This is great for if you have it in your wallet. It has a keychain and it's got an extendable antenna for longer distance. Very compact, very nice. So what if you didn't want to use this very specific antenna? Now mind you, some pledges don't come with wireless control. I've asked for an extra $10 to add in wireless control. So pretend that you have this wireless transmitter and you want to open it up. You want to make a little handheld project box that allows for you to activate and deactivate the system. You don't want to use this little key fob. So what I'm going to do is I'm going to open it up. I'm going to tell you how to modify it. There are 3 tiny screws on the back. You're going to need a tiny Phillips head screwdriver to remove those screws. This might be difficult for you to see, but this side is negative. There's a little negative on the battery. And this side is positive. Remove the battery and keep in mind which side is which, because you don't want to reverse polarity on this or else you'll damage it. So remove the battery very gently, keeping in mind its orientation. This is the front of the module. You'll notice, of course, that there are 4 buttons. If I turn around the back, you can actually see where those 4 buttons are soldered. So what you want to do is you want to add 2 wires in parallel to one of these buttons. So what you'll notice is that the bottom pins for every switch are connected together, and the top switches or top 2 pins of each switch are connected together. So if I want to use, say, this switch, this one right here, what I'm going to do is I'm going to take a wire and I'm going to solder it to this pin and another wire to this pin. Then I can take another switch, a momentary switch, a bigger one, a cooler one, and I can put this in a project box, of course with the battery back in it. Preferably, you'd put this back in the protective casing, then put it in your project box and have your 2 wires protruding from the project box. Then you could add a nice big special fancy looking button. So what you'd end up having would be, now what, just pay attention to this. Something like this, a project box with something like this. Now I don't have this mounted, but this is a momentary push button. Actually, this is a locking push button. You can't use a locking push button, but what you'd want is essentially a momentary push button, so every time you pressed it inside your box, you know, it activated, deactivated the system. It's really neat, and it's just an idea, just something that you can do. I just wanted to show it off as part of this video manual. So I believe we've talked about everything. Thanks for watching. If you've pledged towards a Kickstarter, I really appreciate it. When the Kickstarter's done, I'll have this up at engineeringshock.com, electroniclessons.com, and likely at paintballprops.com as well. Thanks for watching, everyone.